Hi guys, in this video we will be solving this problem, one repeating and one missing. So let's first understand what the problem says. The problem says that we will be given an array of length n. So if n is the length of the array, then it denotes that all the numbers present in this array will be in the range 1 to n only. Okay, but one more thing is there, that all the numbers will be in this range 1 to n only, but one of the number is missing and one of the number is present two times. So let's suppose that n equals to 5 is given to us. So let's suppose 1 is present. All the numbers will be in the range 1 to 5 only. 1 is present, let's suppose. 2 is also present. 3 is present, let's suppose. 4 is not present, 5 is present. And instead of 4, let's suppose any one of the numbers can be present. So let's suppose 2 is present instead of 4. Okay, so one number is missing. One number is missing. Okay, and one more thing, one number is present two times. One number is present two times. So these two are given. Now we are asked to tell which number is the missing number and which number is present two times. So this is asked to us. So we know that missing number is 4 and two times which number is present two times. So 2 is present two times. So this is asked to us. Okay, so this is for the problem. Now let's see how can we solve this particular problem. If we look only at this set of numbers, that is 1 2 3 1 2 3 2 2 5, and if using only these numbers we want to calculate which is the missing number or which is the number which is present two times, it would be difficult, would not be able to apply any of the bit manipulation tricks, like it will be difficult. So what we are going to do is that we are going to use an idea of an already solved problem. Okay, so if you remember, we had already solved one problem with the names. I don't remember the exact name, but the idea of that problem is that all the numbers are present two times except two numbers. So it will be something like this: all present two times except two numbers. So it would be something like this: 1 is present two times, 2 is present two times, 3 is present two times, and 4 is present one time, 5 is present one time, and 6 is present two times. Now we were asked to tell which numbers are present only one time. So we can see that 4 and 5 are present only one time over here. So this problem we had already solved and we know how to solve this particular problem. Okay, what we are going to do is that we are going to reduce our problem into exact this problem. How we are going to reduce? Let's see that we are given only this set of numbers, means n equals to 5, and we are given this set of numbers. Okay, so one more thing was given to us, that if n equals to 5, then all the numbers would be in the range 1 to n, that is 1 to 5, but one number is missing and one number is present multiple times. So what we are going to do is that we will again write all the numbers in the range 1 to n equals to 5, then all numbers should be in the range 1 to n. So we'll write all the numbers in the range 1 to n. So what we'll get: 1 2 3 4 and 5. Okay, now if you look at this problem has reduced to this particular problem. Here also all the numbers are present two times except two numbers. Look clearly, this number is present two times, this number is present two times, this number is present two times, this number is present two times. Only 2 and 4 are present one times, and this is the exact same problem. So here also all numbers present two times except two numbers. If we have reduced our problem into this particular problem, what we did, that we added an extra list of numbers, that is nothing but all the numbers in the range 1 to n, and our problem got reduced to this particular problem. And we already know how to solve this particular problem, so we can very easily solve this particular problem. Okay, and I am assuming that you guys know how to solve this particular problem. There is a dedicated video for this particular problem, but still I am going to give you guys a rough idea. How we solve this problem is that we first take XOR of all the numbers. So if you take XOR of all the numbers, 1 XOR 1 XOR 2 XOR 2 XOR 3 XOR 3 XOR 4 XOR 5 XOR 6 XOR 6. So what we will see, that same numbers cancel each other. XOR is 0, 2 and 2 will give 0 XOR, 3 and 3 will give 0 XOR, 6 and 6 will give 0 XOR. So finally we will be left with what? 4 and 5. So if we take a XOR of 4 and 5, we will get something like this. If we take the XOR of 4 and 5, so we will get 1 0 0. So this is what the XOR is. Okay, so we will calculate the rightmost set bit mask for this particular number. So the rightmost set bit mask for this particular number will be what? 0 0 1 only. The same number will come. This is a particular case in which we are getting the same rightmost set bit mask, but it will not be same every time. Whatever it is, we'll calculate the rightmost set bit mask. So what we are getting? 0 0 1. So out of all these numbers, what will be the case? What will happen is that some numbers at this particular location, that is 0th bit, some numbers will have 0th bit as 1 and some numbers will have 0th bit as 0. We know that 4 and 5 have different bits at 0th position because we are getting a 1 in the XOR. So 4 is having 0 and 5 is having 1 at the 0th bit position. We want to separate 4 and 5. So what we will do is that amongst all these numbers, whichever numbers have bit 1, I will XOR them, and all those numbers which have bit 0, I will separately XOR them. Okay, so what we will get? Let's see what will happen. Let's see. So what will happen? Our bit, this rightmost set bit mask is 1. We will check 1 has one binary representation 1. It has 1 at this particular position, so I will take 1 in this particular list. Okay, 1. Now again 1 came, 1 XOR 1. Let me write it over here a little bit. It will be 1 XOR 1. Now I'll move on to the next character 2. 2 has 0 1 0, so 0 is present at this particular bit, so I will take 2 in this list. I will move on to next 2 XOR 2. Now I'll move to next number 3. 3 can be written as 0 1 1, so it has 1, so it will come to this list 3. Okay, now I will move on to next character 4. 4 can be written as 0 not 0 1 0 0, so it has 0, so it will come to this list. I'll move to 5. 5 can be written as 4 1 0 1, it has 1, so 5 will come in this list. Okay, I'll move to 6. 6 can be written as 4 1 1 0, so it will come to this list. Same for this. Okay, now I will take the XOR of these two lists separately. So what I will get? 1 and 1 will cancel each other, 3 and 3 will get cancel each other. I got 5. 2 and 2 will cancel each other, 4 not 4. 6 and 6 will cancel each other, so I got 4. So I am getting both of these numbers, 4 and 5, so I will print these numbers. Okay, so the same idea I am going to use it in this question, because this question I have reduced to what? Exactly same question, so I am going to use the same idea over here. If you still have any doubts in this particular approach, I will suggest you to watch the video, because we have a dedicated video on this exact question. Okay, so we are now moving on to the solution part for this video. So let's try to code this video. So okay, so we are given a function, we have to write this function. So okay, let's say we have to first, what we have to do, we are taking the XOR of all the numbers. So what are our numbers? The numbers present in the array plus all the numbers in the range 1 to n. This is our number, so we are going to take that. Let's make a variable XOR equals to 0 for integer element in vector 1. What we will do? XOR equals to element. Okay, now for integer I equals to 1, I is less than equals to vector 1 dot size plus plus I XOR into equals to element. Okay, now we get the XOR. After getting XOR, what we have to calculate? We have to calculate the rightmost set bit mask of the XOR. So let's calculate mask. Mask will be what? XOR and minus of XOR. Yeah, so you might be thinking what I have written why XOR and minus of XOR. So for any number n, if you want to calculate the rightmost set bit mask of n, it is nothing but it is equals to n and minus of n. Okay, we have a video on this particular topic, means concept also, why rightmost set bit mask is equal to this particular formula, and proof also. So if you want to refer that, you can refer that. For now I am assuming that you have already watched the videos, so you know how we get to how we are getting this particular formula. Okay, so I am directly using the formula for now. So after calculating XOR, what we were doing, we were separating it into two numbers. So let's make two numbers, answer 1 equals to 0 and answer 2 equals to 0. Again we will iterate. So for integer element in vector 1, if element and mask, if it is equals to 0, then it is one group. If it is equals to 0, then answer 1 XOR equals to element, else what we will do, answer 2 XOR equals to element. Same we will do for the range of numbers 1 to n also. So for integer I equals to 1, I is less than equals to vector 1 dot size plus I. We'll write the same logic, same thing. Let's copy paste it over here, but instead of element it will be I. Here also it will be I, here also it will be I. Okay, after that calculating that we will be getting both the numbers 5 and 4. But what we have to print is that, what we need to print, we need to print which is the missing number and which is the repeating number. So how we'll find that? Let's suppose after this, what would I have got? I would get that I'll get something like this. After calculating this, I will get one answer as answer 1 equals to, let's suppose 2, and answer 2 equals to 4. I got these two numbers. Now I want to find which one is the missing number and which one is the repeating number. So for that, what I will do, I will travel in this array. If answer 1 or answer 2, any one of these is equal to this number, then what does it means? It is repeating number. So no one of them is equal, so we'll move on to the next character. We are seeing that answer 2 equals to this. It means what? 2 is the repeating number and 4 is the missing number. So we are going to use this logic. So let's travel in the array for integer element in vector 1. We will check if element equals to answer 1, then we will do something, else if element equals to answer 2, then we will do something. And what we have to do, we have to print if element 1 equals to answer 1, what we have to print first? Missing number. So here it will be missing number followed by this equals to what? Missing number is answer 2. See out the repeating number will be what? Answer 1. After that we need to put a break statement. Okay, same will be for second case, but here it will be reverse. Missing number will be answer 1 and it will be answer 2 is the repeating number. Okay, so this was for the coding part. Now let's try to run this code. We are getting some error. Integer XOR unexpected qualifier because element XOR expected primary expression before. Okay, why are we getting this? Mask equals to XOR and minus XOR. Okay, 1 second. Control C, Control V. Let me replace it XOR with XOR. Let's try to replace this and let's see what happens. XOR with XOR. Okay, so we are done with this. Yeah, mask, maybe there could be error because of XOR. Let's see if there is any more error. XOR, it is due to XOR. Okay, one more thing, element was not declared in this scope. For integer, line number 7, I less than equal to vector 1 of size, it will be I over here. This was an error. Line number 7, mask equals to XOR and XOR. Okay, I have done that. Mask XOR. Now let's try to run it. It is given correct answer. Let's try to submit it. Let's see what happens. So it is passing. So this was for this particular video. So I hope you guys would have enjoyed the video.